Hi again.
We're back again. Sorry there, we thought we had no audio, but apparently it's working fine, even though we can't see it in the software here.
Yeah.
So just to recap, yeah, we're going to show you the mono amplify kit today.
Mhm.
I think if we just go back over this,
Yeah,
yeah,
sure,
just
absolutely.
so that people can uh, get it clearly. So we've got the three versions of the kit we sell online. There's this one here, which is the one where you solder all the parts in yourself, but it's still not a complicated build.
Hmm.
We have the version where it's like that, but the resistors and capacitors are already pre soldered on, which we can see just here. But yeah, so that saves a little bit of time, costs a little bit more money, but if you don't want to do so much soldering, it's an ideal product. And then we do a version with a switch and an LED, which we can see here. Again, extremely easy to build and a fraction more than the cheapest one, but still very affordable as a product. Okay, so I'm going to now show you what this looks like in a bit more detail on this downward facing camera, if that's okay, Emma.
Absolutely.
So here we can see that the parts you would get in a normal version of the kit. So you can see it's extremely simple. We have the key part, which is the PCB here. For a few years now, we've been mounting the amplifier IC onto the board. That's because as time's gone by and technology's moved on, all of these kind of parts now are produced in this kind of surface mount package, and that's not really practical for a student to solder. So we do this ourselves. We actually have recently moved to one that's even smaller than the IC you see here. Again, because of movements in technology, things get smaller over time. But basically, the chip's mounted. And then you're left with a few parts that the students would solder in. We have some capacitors here. You can see two different varieties, a few resistors, and then the parts that you would need to connect with wire. So we have a speaker, you can see here. On the back of it's the terminal blocks, the solder terminals that you would solder to. A battery pack, and these more modern kits here, they're using AA batteries. So many years ago, we started off to get high or good audio output, you had to use a lot of voltage, so 9 volts or 12 volts. So we typically used a 9-volt battery. More modern chips, like you can see on the board there, are much more efficient, and we can now use just AA batteries. So two AA batteries will power this kit. You could, if you wanted to, also power it from a 5-volt supply. So we do little USB adapter boards you could use to power this if you wanted to have a plug-in main supply. And then we have the cable here, which plugs into the 3.5mm device and then solders into the other end of the PCB. And those connections are made to these points here on the bottom of the PCB. So it's a very, very easy kit to build. We've sold tens of thousands, hundreds of thousands of these kits over the years. They've proved very popular with students. Yeah, so they really are a nice little product. I think now might be quite good to maybe show some of the things you could do with
Yeah,
this.
absolutely. I'll swap places with you and
So move this on. Yeah, I can just quickly show you this. This is how a built one looks. You can see
uh,
it's really simple. Jack lead off the side there, and all the soldering's occurred on the back. Let me that your way around.
thank you. So I've got a few examples here of some pre-built, not pre-built, but some kits that have been built before. So most recently, I designed a sort of fake guitar amplifier style um, mono amp kit. Um, and this is just a really, really simple design. I just wanted to show you exactly how it was I mounted the speaker, because this is something you want to pay attention to whenever you're uh,
Design. Yeah.
designing your kit. So if I just bring this speaker down here, what that panel there does is there is one on the inside of this, just behind this front panel here, and it's slightly smaller than the speaker itself. So when you have that pressed against, so this grating or
Like
I
a
suppose
group.
mesh
Yeah.
is made from polypropylene, so it will actually hold it in place when there's polypropylene sort of glued into this space here. Um, but it's
So you sandwich the two there.
yeah, sandwiching the speaker in is a good way to hold it in. Now, if I show you a different example of something that has been 3D printed, this keeps the speaker in place in a far different way. So this is an older design made by a previous designer, and so it opens up just like this, and you've got these clips that hold the speaker in place. Now, regardless of what how you keep the speaker in place, you should always sort of think about how your cable's going to go back into your enclosure. Just keep that in mind, especially if you're going to do the sandwiching method, because you sort of have to put the cable through the panel, which sometimes sometimes you have to put the cable through first before you do any soldering.
So you put the cable through, then solder it to the speaker.
Yes, yeah,
Okay.
yeah.
Hmm.
And so here is an older. This one actually you may recognise from the front of one of our older D&T catalogues. So this one has a little switch on the top of it.
Yeah. So this is as normal kit, isn't it? It's not
Mm,
the one with the switch,
mm,
but it's possible to add a power switch in should you wish to.
mhm.
So I mean, what you would, I can't really show you here, but you would put the switch in line with the battery power supply. So the positive from the battery would go to the switch, and then you'd have the output of the switch going on to the PCB.
Yeah.
So it's really possible to add any kind of switch, should you wish, to any of the kits.
Mhm. And transparent, always nice. You can always, seeing the insides is always a nice touch.
So how's the speaker mount on that one though? Is that sandwiched?
This one is sandwiched. You can see there is a panel which sort of has a little finger joint that sticks through the top there. Let me.
And that's sandwiching that against the front face.
Yeah, and that's sandwiching that against this grill here.
Yeah.
So again, sandwiching is another good way. Generally, you just don't want to be touching this part of the speaker because it'll dampen the sound. And
Yeah, because that's moving, isn't it?
yeah,
It's straight in the audio.
and here's another example where a switch has been added to one of the normal kits. So this it features a living hinge. We love living hinges.
Yeah.
But you can see on the back.
So gains use a different power switch that's been wired in. That's like a
Mhm.
panel mount one, so they mount flush into a set size hole, don't they?
Yeah.
They're like
Yeah.
friction fit and clip in place.
Yeah.
So they look quite. I think they look quite professional. That style
Yeah.
switch.
Yeah. They're quite sleek looking. And again, if you wanted to get a little bit fun with your 3D printer, you could do something like this.
Yeah.
Which is very, very aesthetically pleasing.
That's got like a clip in the front that holds it in
Yeah.
place. It's quite difficult to remove.
Yeah, it is quite difficult to remove, but this here sandwiches the speaker in place again. So that's sort of that's some inspiration as to what you could possibly do, and just as a final thought on that as well, you always want to be thinking about where your jack cable is going to be coming from.
Yeah, I mean, unfortunately, these aren't like a Bluetooth amplifier. We do sell Bluetooth amplifiers, but they're
Exactly.
obviously much more expensive. I mean, I think this is quite an interesting one you've designed lately, though, isn't it? Because you've used a variety of materials in here as well, haven't you?
Yeah, this is laser laminate, polypropylene for this grill here, which I didn't expect it to work as well as it did, but it's we found a new hack. We've got some little rubber feet here. This is black 3mm Perspex. So yeah, it's a variety of things. You could really impress your D&T teacher if you did something like that. Yeah. So
I think it's a really, really nice sort of project, and you've got battery access.
yeah, there's a battery door.
Yeah, I just think it's nice because you've used such a variety of things in there. I mean, all of these designs that Emma's just shown off, we do have a resource for these on our website. So should you wish to build them, all the design files, etc., they are available, aren't they?
Yeah, let me I can bring up the There we go. So this is the blog for the resources. To access the resources, you just want to go to resources and then scroll down to Inspire Me. That's where a lot of these makes and tutorials will be. So this one, actually, if you wanted to recreate the one that I've made, I have provided the DXF file for the blog, so you can
You can import that into whatever
yeah,
software you're using, can't you?
exactly, yeah. So you'll end up with, and I've given you some labels as well, just to show you exactly what everything is on the DXF. So we do have also a very exhaustive list of, you know, what we've used here. So yeah, if you would like to recreate that, you'll be able to find that on our website. And
Yeah. I mean, I
there you
could,
go.
if you sort of, maybe we'll go back to the main screen for a minute.
Absolutely.
Yeah, so I hope that sort of gives you some ideas around what you could do with these kits. I mean, the kits, I say they run between, I think it's 2.5 and 5.5 volts. Can you just go onto the product page a second? Sorry,
This one?
Yeah, go down. So I'm pretty sure it's 2.5 to 5.5 volts.
Yeah.
Yeah, so like I say, down to 2.2. So 2.2 volts is nice because that means you can get a lot of capacity out of your AA batteries. But the 5 volt does give you a whole host of other options to power the board should you not wish to use the batteries themselves. So like we talked about earlier, it could be USB powered, it could just be a 5 volt power supply. So there's there's ways of doing it without the use of batteries should you wish. And these modern chips are good. They're the 1 watt output doesn't sound a lot, but 1 watt is quite powerful, and it gives you that 1 watt even at these lower voltages. So like I said before, some of the older ones, they were maybe 1 watt, but 1 watt if you had 12 volts, which most people didn't, so they're actually a lot quieter. So these newer versions of the kits, they do give a good audio performance. The other thing I have seen people do, and it's something you can consider should you wish, is that these speakers that come with the board are nice, but we do a variety of different speakers that you can use should you wish. Some are high quality and offer a better sound. Obviously they cost more money, but there may be things to consider. These are paper cone speakers. We do ones with like a plastic cone, which are suitable should a student be looking to design something that they're going to leave outside, and the weather may get out of them, because obviously paper over time with water around wouldn't do great. So there are, even with the kits here, there are ways you can tweak them and alter them should you wish for your use. So yeah, I mean, the other thing I'd like to show is we've got some examples from the students' work. And the student work is all linked off the main product page. You can go to the bottom and you can look at examples. So we've got a couple here we've opened up. So this is from back in 2014, so quite a while ago. So this will use an older version of the amplifier. So you can see here that the chip on the board is a bigger through-hole one, where the student would have soldered in an IC holder, but it does the same job. So that's some quite nice examples. We've got ones where students have designed with concrete, which is the next one along. So yeah, so this is use of a different material within design and technology. They cast these concrete cubes and then made a perspex or acrylic insert for the front, and the amplifier goes inside. I'm not sure if there's any pictures of that further down, can't quite remember, but yeah, so that's quite a nice, and they came about because we were originally doing this with design students at Nottingham Trent University. So they were doing it in their product design class, experimenting with different materials, making these casts here, then casting the concrete, and then putting the amplifiers inside. So I mean that was quite nice. Yeah, and then they're embellishing them with graffiti, Banksy style kind of artwork there. So it's quite nice. And is the last one another example?
That's
That's your example, yeah. But if you go back to the main this page here, I mean, this is the bottom. Keep going down, and then we've got project photos. So this is where you would find the links to the student example. So there's lots there. You can see different students have done different things with these kits. If you've used the Amplify kits and you want us to include your students' work in here, by all means send them over to us. It's something we'd love to have on the website. It's always good for, I think, for teachers to see examples of what other students have done with a project. But yeah, there's a whole different varieties. Ones here, some that are quite fluffy, ones with laser cut like wood cases. Some are vac formed, some are handmade. So there's quite a variety of things you can do.
Yeah, it's a nice place to come and get some inspiration.
Yeah, I mean, we see this kit, what I do, as something that's been easy for a student to build, but offers a lot of design opportunities around the outside of that. I mean, you can see we've got, you've done your modular style amplifier.
Yep.
We've got 3D printed amplifiers up to concrete creations. So there's a whole range of choices that are available to you there as from a design point of view.
Absolutely.
Okay. Is there any questions?
No, not that I can see.
No. Well, I'm hoping that means we're either really clear or nobody can hear us.
Yeah.
So there's a point in there somewhere. Okay, but by all means, we'll put this video live afterwards on YouTube. Should anyone think of any questions afterwards, whenever, by all means, comment on there, and we'll do our best to come back to you and help out where we can.
Absolutely.
All right.
Amazing.
It's quite a quick one today. We'll do more of these on these kind of project kits, and then we're going to do some more slightly more technical talks in a few weeks on some of our more exciting new products for computing. So yeah, stay tuned. Yeah. Okay.
Thank you, everyone. Hope you have a wonderful day.
All right. Take care.